Okay, let's get started. Hello, everyone. Thank you for joining us. Today, we're going to talk about real-time analytics for overall platform monitoring at Poshmark. Um, it is presented by me. I am Mahesh Pasupuleti, VP of Data and ML Infra at Poshmark, and also I have my coworker Gaurav, Director Data and Machine Learning Infra at Poshmark. Hope you're all having fun at the Druid Summit. So I want to give the way the presentation goes is I will give you a background about how we came to a Druid based real time analytics solution and how the journey before that. And Gaurav will talk about the journey with the Druid and how we put the whole end to end solution together and how we use it for business monitoring. And I think we have a fairly small group, so we're going to keep it a little more interactive. Feel free to ask questions, and we can make this more interactive conversation. So before I get started on the tech side, I want to give you a little bit of background on what does Poshmark do. Poshmark is a social marketplace for both new and used items and styling for men, women, and we have kids, pets, and many more categories and departments as well. Um, at Poshmark, we combine human connection of physical shopping with scale and ease and benefits of e-commerce. We make buying and selling very simple and also social and sustainable. We have a community of more than 80 million users across US, Canada, Australia, and India. I, and we are driving to reshape the future of commerce while promoting sustainable consumption. So that's what we do at Poshmark, and our users use the platform every day and do different interactions with the platform. Um, what we call those interactions are called poshing. On our platform, our users do poshing. The way they do poshing is they create new products. What we call that as listing the products. Once they create the products, they share the product with their followers within the platform or outside the platform as well. And the shared products appear on users feed, and users browse the feed, and they comment, like, share, follow each other, and the process they also buy from each other. Most of our users are both buyers and sellers as well. Okay. Different metrics we monitor on the platform. We monitor thousands of business metrics, from from how many active users are coming back to the platform based on when they join, or the GMV, gross margin value, of different apps and different versions of the apps, and list of products created, and number of shares or comments, other likes and follows, those social interactions, how many are there happening, and how new users are performing the platform, how the new users are converting to buyers, or how the new users are converting to listers, etc. And we also measure activity of different cohorts. We run a lots of experiments, and we also measure the performance of different user segments based on experiments as well. Okay. Before we adopted Druid, we had our own real-time reporting solution, which was a homegrown real-time reporting solution. It was based on custom event logs. Every time we wanted to monitor something, we wrote in an event log. When that action is performed, we wrote an event log that is very custom to that particular action. And once the event log is received by the reporting system, it does all the computations. Sometimes it pre-computes the data, it saves the computed data, and sometimes it saves the raw data, and it was all pretty ad hoc, and it all depend on who wrote that particular report and how they intend to consume, and there was no standardization at all. Um, and it was also built on a non-sharded database. It didn't allow us to scale. There was no particular reason why we didn't use a sharded database. We just choice we took, and because the scale of the system, we didn't really put in effort to make it sharded, but different logs could be saved on different databases. So that's how we scaled it. No standard process for relaying missing events. Whenever there was a hiccup in the system, we didn't have any standard process for uh, replaying the missing events, so that data can be corrected in the real time in the reporting system. So when there were data gaps, some of our users will let us know, and we go in, write custom scripts that which would take a couple of days to a week to reprocess all the missing data, so that reporting system data accuracy is good. Tools and technologies we use for this was Ruby, MongoDB, and D3. So this this particular homegrown solution did its job. Um, Basically, it provided a framework for us to monitor key business metrics, and we also use the system to develop standardization of reporting interface, how we look at different business metrics with the same understanding the data by different consumers. Uh, but as the system grew, it became very complex. It was harder to maintain, and we were spending more time managing it um, and patching it. So at the same time, another technology evolution also happened. Um, the event logs I talked about was fairly um, custom event logs. There was no standardization, so that was only used by that particular reporting system. No other parts of a data system could take advantage of that. Like, for example, data analysts couldn't get hold of those event logs because they were so complex, and it was harder to be read by any of the processing engines like Spark or other systems. So it was done for one purpose, and that one purpose only. So what we did was we revised our data collection framework. We introduced a new concept called clickstream grammar. This is a very common concept in the industry. All the systems will have its own grammar. Google Analytics uses its own grammar. Um, Snowplow uses its own grammar. How we came to it, our own set of grammar, we chose inspiration from activity stream. Oops. Okay. All right. Activity stream is a it's a spec, and I was trying to show the URL here. I couldn't show it, but you can Google it, and it's a 2.0 spec now. It has very similar concept as what we have. So basic objects on the event grammar is actor, verb, and a direct object. A simple example of an actor is a user or a visitor. So examples of this grammar is user views a page. That means user navigated to a product details page, user navigated to profile page, or user is looking at an order page, something like that. User book an order, that's an action. It's a event generated by backend systems. It means that user placed an order. Um, User shared a product. Um, User is sharing a product with their followers, etc. There are much more complex um, attributes of this grammar. I'm not showing them for simplicity, but this sort of grammar allowed us to have a uniform understanding of what data is captured within our data lake, and how this data attributes are understood by different parts of our data system. I will show you a quick example, JSON example of how that event looks like. I think it's a smaller font, but I'm not sure I can zoom in at this point. But I will read it through. An actor contains a type of the user, what type of the actor it is. It could be a user or a visitor, what kind of segments they fall into, what is their joining date, etc. and and also what kind of action that user has done. It's a click action in this case, and it's performed on a page called edit listing, and a direct object is a page element. So that's an example of it, and we also have elaborate collections of this that includes with, for, and other examples as well. This allowed us to simply specify which attributes um, of different objects, where they fall in, and how we can understand it in uniform way. So the power this unified grammar allowed us to write very standardized queries across different data systems. We use Kubo, EMR, and also Databricks uh, to query our data lake data, along with Redshift and Redshift Spectrum as well. Uh, in Kubol and EMR and Databricks, we use Spark-based system, and on Redshift Spectrum, it's Redshift proprietary um, grammar. But in both cases, the SQL looks fairly similar, and it is similar way of querying within Druid as well. So that was the power that Clickstream Gravity provided us, so that we can use simple understanding of what the data lies in our data lake, and how to have access to it. So in this example, I'm showing how to querying of query tuple users receiving specific email communications. So these user in the first query, we are querying all the users who received a notification that type of notification is notify greeter, and the communication method they received this notification. Similarly, the query below shows us query tuple list of active users. Okay, moving on. Why, as I was explaining, the benefits of standardized grammar, data lake storage is consistent with data capture, sample query for different query engines, Spark, Druid, Redshift and Redshift Spectrum. Um, Data quality checks were consistent across different storage formats and with different query engines. We have developed a quality checks framework as well, and because our storage format, not storage format, but how we store the elements is so consistent, it was easier for us to develop those quality checks as well. Side benefits, it's also allowed us to come up with the right partitioning strategy, also democratizing data usage. Okay, now Gaurav will talk about how we use the standardized grammar across different parts of the ecosystem of our data infrastructure ecosystem, and also deep dive into our Druid deployment architecture, and what are the knobs we use to optimize the cost, along with the future, and what are the challenges we had. Thank you. Gaurav, you want to start sharing, or you?
You'll have to pause Mahesh, and then I will be able to share the screen. Okay, thank you. Okay. Hi everyone, good morning or good evening, or depending upon where you guys are. So let me start sharing my screen, and here we are with the architecture. So at a very high level, we have multiple different applications. We have iPhone app, Android app, we have a desktop web application, we have tablet applications as well. All of these interact with our subsystem using standard REST APIs. This is how any applications would work. But beyond this, focusing on how our tracking works, there are two portions to tracking that we have. we track all kinds of client events like clicks, views, and scrolls, and all of those get fired to tracking server, similar to how Google Analytics takes place. And on the other hand, we also capture all of the events happening on the server side. For example, an order is placed, a like event has happened, a share has happened. Put together all of these events together is what we call as our clickstream dataset, and they all get moved or transported to Kinesis. Now, Kinesis is a buffer. It's a streaming engine which helps you buffer data for X hours, and then you can have multiple consumers read from it. One of the consumers here is Druid, and we use Tranquility to ingest data into Druid, which is then visualized by Grafana. Uh, we have other consumers on our Kinesis pipeline. One of them is our Spark streaming engine, which takes data from Kinesis and stores it in Data Lake for different processing and different details on top of it. Separately, let me touch base on this alternate pipeline that we have. We have MongoDB as our primary database for transactional needs. We use proprietary system to take the data from Mongo and move it to our data warehouse called Redshift. Redshift is similar to Vertica or other OLAP databases used in the data warehousing world. And these are the two systems that we have to look into the data that we collect. So just revisiting this, we take data from our different devices, push it to tracking server or the app server, which flows through Kinesis, use Tranquility to get to Druid, and then visualize it through Grafana, right? Coming back to our infrastructure, how have we provisioned it to give some details around it? So we use Tranquility. As I mentioned earlier, we have 10 nodes. The reason we have 10 nodes is to allow us for the scale that we are processing it. Simply put, more nodes is more number of events that we can process. On the historical node section, we have opted tiering methodology that Druid recommends, and we have split into two different tiers as of now. One is hot tire, one is cold tire. Hot tire stores the recent 90 days worth of data and previous year's 90 days worth of data. The reason we store 90 days data this way is because a lot of feature testing, a lot of rollouts are dependent upon the most recent data, and also the comparison in terms of how does the data look last year. This enables us to look at this recent data with better SLAs, with less than 3 seconds on dashboard loads and things like that. On the other hand, we have cold tire, where we store the remainder of 3 years worth of data into 20 nodes, which of course has different SLA requirements, but then it helps us benefit around the cost. The other subsystems like Zookeeper, Coordinator, Middle Manager, they're all being put in standard frame of how Druid recommends, deploying multiple nodes to ensure HA. Middle manager we have deployed in the sense we have multiple middle managers just to enable us duplication, in the sense that all of the data is being processed by two middle managers at any given point in time. The segments are always duplicated, so that even if one middle manager goes down, that is always a copy of segment, even on the real time, to make it available at any point in time. On the UI front, we use Grafana, and similar concepts are applied, where we have multiple different nodes to provide for HA. One of the challenges that we had when we initially started with Druid was we were using Kinesis instead of Kafka, and Druid supported only Kafka ingestion at that point in time. We had to write our own Kinesis consumer, which we contributed back, and now we are able to use Kinesis with Druid. Now, coming to the performance challenges. Now, one of the challenge at Poshmark is that we use wide set of metrics to look at. We have 60 plus dimensions to slice data. We want to look at data by segments. We want to look at data by demographics. We want to look at data by cohort. We want to look at data by what are the different apps they are using, what are the different app versions they are using, just because of the social nature of our ecosystem. Now, this means that more dimensions is more data, simply put, and that makes it complicated or challenging in terms of how we can store all of this data. So some of the techniques or experiments that we tried in terms of improving performance or reducing cost are as follows. One is to begin with different granularities. We started realizing that we don't have to store all of the data at minute granularity. So we said that let's store the initial 10 days at minute granularity, and beyond that we store it at hour granularity. This literally saved us 50% of space on per day segment size. And this in turn reduced cost and also gained performance accordingly. The reason why we have 10 days stored as minute granularity is so that we can deep dive to any peak or any dip and immediately figure out the issues. Beyond 10 days, the real value or the value of this data at minute granularity diminishes substantially, and hence it makes sense to just store it at our granularity. We always have the data stored in data lake, and people can always deep dive. Of course, that is slower than querying Druid, but we do have alternate ways to query that data. The next thing that we did is, instead of monitoring performance at a broker level to benchmark system, we said that, let's monitor Grafana dashboard that gives us true experience of a user. So what we did is we picked all the critical dashboards based on the usages, and then we tried to maintain SLA of 5 seconds where all of the dashboards are loaded and all the panels are loaded, which could mean 5 queries, which could mean 10 queries, which could mean even 20 queries. But the idea was to ensure the user experience is met when we are trying to do performance and not just deal it at the broker level. This made us understand that tiering is what would help us out, because most of the dashboards focused on recent data and not on the whole data set. And this is how we came to doing cold tiering and hot tiering. The other thing that we did was look into different EC types. We experimented with M, we experimented with R, and we experimented with T. There is no simple rule of thumb that will work out, but for our use case, what worked out is burstable instances, T instances. The reason why they worked out for us is because our query pattern is pretty sporadic. When there is debugging, there are a lot of people querying it. When there is no debugging, there is a different workload. And given the burstable performance of T instances, they gave us the burst of performance at peak that we needed without having to wait for new EC2s to be spun up or things like that. The last optimization that we applied was compaction. We realized that as going from minute to hour was important, we also realized that some of the dimensions didn't make sense. For example, looking at the segments after 90 days didn't make sense because all of the tests are anyways rolled out in this 90 days period. So how does it help continuing having those dimensions? So when Druid introduced compaction, we immediately piggybacked on it and we started removing dimensions, which in turn reduced our storage cost, at the same time improved on our SLA. Moving to the next slide, how do we do monitoring? We have 3 pieces of monitoring. Infrastructure is the simplest. That's the integration of Datadog, and we push all the metrics from Druid, Kinesis, and Grafana to Datadog, and we have all sorts of alert to ensure that the systems are up and running. We also got metrics from Kinesis as AWS metrics, which helps us understand how much we are falling behind in the streaming process, etc. So that was the simpler part. The next thing was, how do we ensure that the data itself that we are getting is correct? We built alternate systems where we have Mongo data or our transactional database data flowing into our data warehouse, Redshift. And we built plugins on top of Grafana that helps us compare the data across Druid and Redshift onto a single dashboard panel, and then immediately know if the differences between the data from these 2 subsystems are exactly 0. Since these 2 systems are completely independent, it guarantees us that if the differences are 0, the data is absolutely perfect. The next thing is about reconciliation. Now, every time or every now and then we could have a miss in terms of events. How do we ensure that the data is absolutely accurate? One of the simplest way is reprocess the data every night. I know it might sound very counterintuitive or inefficient, but in terms of business, it's a small cost. The cost that you have to pay while you're debugging a problem higher than what you would spend on doing a reconciliation is what we call. So every night what we do is we take the data all the way from logs, make sure we reprocess it, get to the pristine state, replace it back at Druid. This ensures no downtime, at the same time ensures everybody on the business is looking at the same data, whether they are looking at it in Redshift, Druid, or S3. This ensures that we spend time looking at business problem and not dealing with data discrepancy. This was one of the Grafana Druid plugin. This is one of the things that we spent time open sourcing. We had some initial version available out in the world, but we added some enhancements that made it much easier for us to use. So Grafana had a basic Druid plugin. It worked. But then what we added was one autocomplete feature. Autocomplete feature made it it brought us leaps and beyond in how we could build dashboards. Simple reason being the grammar is vast and deep, and to allow everybody to create dashboards, it means that everybody has to remember the whole of grammar. Autocomplete made it very simple for people to create dashboards. Here, if you look at it, people say verb and then say BO book, and it gets auto-completed. Then people search, okay, what kind of values that I look for. You are interested in filling out a metric name. You search for E, and you get event count and things like that. The next thing that we added was time zone support. Druid supports period granularity. Our data is stored in UTC, but as we are expanding to different countries, we want to look at data in different time zones. So we added the ability where you could automatically pick period granularity based on the dashboard that you're looking at. And then that helps us look at day level data in different time zones. Then, of course, we added support for Grafana upgrades as Grafana moved forward and make sure the things work. Right. Then we also added another plugin to Grafana Meta Queries. It helps us compare metrics at multiple different places and or two different sources. Here in this case, we compare systems from Elasticsearch, from Redshift, and from Druid. This helps us ensure, or for example, plot, okay, our feature releases are stored in Elasticsearch, our business metrics are available in Druid, and our transactional metrics are available in Redshift, and we are able to plot all of them on one single dashboard, giving us a clear view that, oh, there is a dip, oh, there is a peak because of a feature release, because of an app release, things like that. The other thing that we added to this plugin was ability to time shift the data. This is very useful when you have seasonality into your business. Poshmark has a seasonal business in terms of week, in terms of quarter, and in terms of a year. So what we do is we compare metrics week over week to ensure that we are better each week. Last Sunday's performance can be compared with this Sunday, and we cannot compare it with yesterday because Sunday is a very different day than Monday for us. So time shift was another thing that we added. The next thing that we added was moving average into this plugin. As you see in this graph, the peaks and dips are fairly high, and it's pretty sporadic. To understand business out of this is very hard. One way to smoothen out graph is averaging it out, and we chose moving average. So this plugin helps you smoothen out the graph and helps you visualize the trends much more easily than having to do it manually or try to spend time just understanding. In terms of conclusion, Druid with Grafana is what we call as Quanta, the whole ecosystem. It's primarily used for monitoring business performance metrics. We have adopted Quanta on multiple different organizations within Poshmark, and we have trained multiple users not only to consume the dashboards, but also to create them. We have taken multiple of their feedback and added enhancements at Grafana layer to make them easy to create dashboards. Grafana is also used for monitoring A/B tests. It decides whether should we roll out a feature, should we graduate a feature, or should we roll back a feature. We do slow rollouts of every single feature that we do, and data is what is used to decide if it should go in either direction. The next thing that we did is we automated the requests to adding new dimension. We get a lot of requests to getting, say, okay, we want an additional dimension to be available in Quanta. We have developed a standard process which goes through a cost approval. We first estimate what it is going to cost us to add this new dimension, and then we go test it around, add it, and make it available in Grafana. In terms of future, how are we looking at our future of Quanta framework? One of the top things that we want to do in terms of future is to figure out a way to enable alerting in different areas. One alert we are looking is to ensure that the data between different pipelines is exactly the same. And today we have some sort of manual monitoring that we do. We are looking to see how we can enable alerting on top of Quanta so that we don't have to have any manual steps. The second is also around business metrics. We have a lot of business metrics and they showcase trends, which we should be able to automate and develop alerting framework on top of it, which means we'll get business intelligence with alerting. So anytime there's a dip in business, we get alerted instead of having to look manually. The next thing that we are looking in future is to measure the usage of Quanta. We know there are multiple different usages happening across different organizations, but measurement is something that we believe in. So once we measure the usage, we will have better insight into where to focus and how to do things. The next thing is Grafana mobile UI. The Grafana does support a responsive UI, but we can definitely make it better. So that's another area that we would like to invest in it. The next thing is we have a decently templatized version of how do we report things. For example, we say all of our tables should show up on the left, all of our graphs should show up on the right. On the graph, the current day metric should appear on blue, previous week metric should appear on green, last year metric should appear on purple. Now, this gives a standardized framework for everybody to look at dashboards. Now, when people have standardized way to look at things, then comparing across organization makes it very simple. I can understand other people's dashboard, they can understand my dashboard, and there is very little time spent trying to just understand what we have built, and helps us enable directly focus on the problem instead of focusing on what is being presented. The last thing that we are looking to focus is around or improve is around real-time reconciliation. Today, we have to wait all the way in the night to reconcile when there is a dip or a miss in terms of events. Real-time reconciliation will ensure more guarantees or a higher confidence in terms of what we are building. So with this, I would like to take a pause and open up for any questions that people might have. So yeah, taking a pause here and open up for any kind of questions. But thank you for being a wonderful audience. I'll wait for the questions. Okay, the first question that I have is from Zeke. What is Tranquility? Is this your own application? No, it is not. Tranquility is something that was available from Druid team. Tranquility was what was available before Indexer, and we haven't migrated yet. Today, Indexer is part of Middle Manager, which consumes from Kafka or Kinesis. But before that, the consumer was a separate application, and Druid built it out. Tranquility earlier supported only Kafka, and we added support for Kinesis. The next question is around how do you store the data with minute and hour granularity, two data sources? No, we have a single data source called as raw events. And the way we do it is we store it initially at minute granularity, and then we do a reprocess 10 days later, and we literally write the data to Druid as a whole segment. Does that answer your question, Frank? Okay, I'm assuming yes. Okay, thanks, Frank. The next question is around where can we find the Druid and Druid Grafana plugin and the Meta Queries plugin? I'll paste the link in the chat once we are done. Let me do that right away. That's for Meta Queries, and I can post in another one for Druid plugin. The next question is around what motivated the observability use case for Druid. Mahesh, can you take that question?
I'm not fully following the word observability here, but basically we wanted to scale our custom reporting solution with a more standardized framework, with the benefit of using the open source tools along with making it easy for technical and non-technical audience to be able to build reporting on their own. Um, and we found Druid plus Grafana ecosystem gave us that. That's why we moved towards that Druid ecosystem. Um, does Redshift pipe into Druid at all? No, it doesn't. We It doesn't go into Druid. We do query from Grafana directly, though it looks like it is coming from Druid, but Grafana actually queries directly through Redshift.
At this architecture, we have Redshift on one end and Druid on the other hand, and Grafana directly queries both of these systems. And these two pipelines are fairly independent, and they do not overlap in terms of uh, one is clickstream altogether, another is transactional data.
Are there any interesting usage patterns that you have noticed through monitoring that you did not know before? Um, the patterns for us is when we do most of our dashboards do year over year diffs, and what and what we noticed that through monitoring and also our own is that we do need to put not only current year's worth of data in hot year but also last year's worth of data in hot year. So instead of putting the whole 2 years worth of data in the hot year, what we did was 3 months this year hot year and 3 months from last as also hot year. And COVID threw us one more variation. What happened with COVID was the yearly seasonality kind of got messed up, so we have to go to current year current year -1, current year -2. So we have to put more into hot year. That was one of the interesting ones that we noticed through monitoring and our own research. Anything else, Gaurav, you want to add?
Of course, and somebody who is trying to wonder how do we manage them, we have specific API calls that we make it to Druid. I believe coordinator, which helps us shift the segments. So every day we ping a coordinator to tell these segments belong to hot tire and these belong to cold, because you can do P and say last 90 days, but there is no simple way to say, oh, do last year's 90 days. And the only way we did it is we added some tooling on top of it that goes and pings every day. Okay, these are the segments that from the last year and last year that have to stay in hot tire.
Yeah. And the other thing was, through monitoring, it allowed us to compare data that is coming from transactional pipelines and also the data coming through clickstream, that allowed us to compare. And when we noticed it, we kind of understand if there are any issues with the pipeline, and we reprocess wherever it needs to be done.
Any more questions, guys? So what other custom components like the hot cold tier movement do you have?
One is definitely around reprocessing. We use two-step process in terms of how do we reprocess our data. We have data lake data in Parquet format. So we first converted to CSV outside of Druid ecosystem. And then we again launched Druid Hadoop-based cluster to do the reprocessing so that there is absolutely zero additional load added on the current system. So we keep our current system independent of reprocessing, ensuring that nobody is impacted. So that's one custom system. We spoke about Tranquility to Kinesis connector. That was custom. And the other custom thing that we have is around the minute to hour granularity. We just have to reprocess. There is no choice. We did know that there is compaction, which allows you to drop dimension, but changing granularity is something that was not available at the time we were looking into doing this. I'm not aware if it is available as of now or not. So I believe those covers all the custom components that we have around Druid itself.
I didn't follow that comment, but
Basically, Frank is letting us know that it's still not supported in terms of reducing the granularity from minute to hour. And yeah, it's still not possible.
okay.
Okay, I think we are all good.
Thank you. It's been super fun. And if you want to get in touch with any of us, here is our email, mahesh@poshmark.com and gaurav@poshmark.com. We really hope to hear from you, and we hope you get to check out the GitHub links to the plugins we have developed.